Alright, so in this problem we are given a table called insurance, and over here each row represents a policyholder with 4 important attributes. First one is the TIV 2015, which is the total investment value in year 2015, right? Similarly, we have TIV 2016, which is nothing but total investment value in the year 2016. Lat is the latitude of the policyholder's city. Lon is the longitude of the policyholder's city, right? Now our task is to compute the total TIV 2016 value, but only for a specific subset of policyholders, right? And when we say specific subset of policyholders, there are 2 conditions that must be satisfied. Now the first condition is that the policyholder must have a TIV 2015 value that appears more than once in the table. So in other words, at least one other policyholder must have the same TIV 2015 value as the current one. Second condition is that the policyholder's location must be unique. That means no other row should share the same pair of latitude and longitude, right? And only the rows satisfying both these conditions simultaneously should contribute their TIV 2016 value to the final sum that we are going to return, right? And we will just return this rounded to 2 decimal places. So maybe let's start by examining the TIV 2015 value. We want to identify the values that appear more than once, right? Now looking at the table, here we can see that the value 10 appears 3 times and the value 20 appears only once, right? So rows with TIV 2015 equal to 10 satisfy the first condition for sure, right? But the rows with TIV 2015 equal to 20 do not satisfy this condition. So therefore row 2 will be excluded from further consideration. Now we check for the unique locations, which is the second condition. So we check whether each row has a unique pair of latitude and longitude, right? Now again, looking at the coordinates in the table, we observe that row 2 and row 3 share the same location, which is 20, 20. Therefore, those locations are not unique, and this means row 3 must be excluded, and even though it had a valid TIV 2015, right, which we saw earlier. Now we just check the remaining rows. Row 1, the location is 10, 10 and it appears only once, and row 4, the location is 40, 40 and that also appears only once. So both these rows satisfy the unique location condition, right? Now what we do is we combine the 2 filters. The rows that satisfy both the rules are these 2 rows, right? With PID equal to 1 and PID equal to 4. And these are the only valid rows. So we simply sum their TIV 2016 values. So row 1 contributes 5 and row 4 contributes 40. So the total comes out to be 45, right? And finally, we just round to 2 decimal places, producing 45.00 in decimal, right? And this will be our final output that we are going to return. So now that we have understood this solution, let's just implement this logic in SQL, right? So we start by creating a common table expression, and this will allow us to compute some helper columns that will make filtering easier for us, right? So first of all, we simply select the TIV 2016 value, since this is the value that we eventually want to sum in the end, right? Now here in the second column expression that you see, we use a window function, right? And this expression over here counts how many rows share the same TIV 2015 value, right? And this will allow us to easily check whether a value appears more than once or not. Now next, on the similar lines, we compute how many rows share the same location. And this window function groups the rows by the pair latitude and longitude. And if the count is equal to 1, the location is unique. Otherwise, there is some other policyholder that shares the same location, right? Now at this point, if you see, our CTE produces a table that contains 3 columns: TIV 2016, TIV 2015 count, and the location count. Now these helper columns will allow us to apply the filters easily. So now we compute the final sum of TIV 2016, right, over this CTE that we just created. and we also apply the round function to ensure that the result has 2 decimal places as is required by the problem. Now, this particular filter condition ensures that the TIV 2015 value appears more than once, right? And this particular condition, location count equal to 1, ensures that the location is unique. Now, after applying both the filters, only the valid rows remain, and we then sum their TIV 2016 values, giving the final answer as 45, right? Now this solution, if you see, is very efficient because it uses window functions, and window functions allow us to compute duplicate counts in a single table scan instead of using multiple subqueries, right? So this makes the query cleaner and easier to read at the same time. As well, it is highly performant, right? Which is exactly the type of solutions interviewers expect in the data engineering and SQL interview rounds. So that's it for this particular problem, and now I will see you in the next one.